Okay, getting back to linear equations, we've been able to take care of with the variable by itself, with the variable on both sides. We've even seen some that have some parentheses we have to worry about. The final hurdle in the task of solving linear equations is the following. We'll start off with that one. Some of you who have not enjoyed math in the past will now receive an antidote to your worries. You see that equation and it looks bad. You think, yuck, who in the world would make something like that? I hate fractions. At this point, you should realize that within yourself are the answer to all your woes. You don't like fractions? Get rid of them. This fraction bar, most people know this now, but if you have a fraction bar right there and you have a number on top and a number on the bottom, it is a divide sign. Fraction bar and divide sign are exactly the same thing. This is 2x divided by 3, and that's 10 divided by 3, and 5x divided by 3, and 7 divided by 3. How do we get rid of divided by 3? We multiply. So this is where the power comes in, and when it starts looking wonderful. Let's get rid of that guy. Okay, so if you want to get rid of a divide by 3, times by 3. Now, when we times this side by 3, he'll jump into here, and he will jump in there. He'll jump in there, and he'll jump in there. And this is what's so nice. Timesing by 3, dividing by 3, they're exactly opposite of each other. Whoosh. 10 times 3 divided by 3, go ahead and punch it in your calculator. 10 times 3 is 30, divided by 3 is 10. They're gone. Those are gone. Those are gone. And what we really have is 2x minus 10 equals 5x plus 7. You're like, doesn't that feel good? Math is nice. Now, when you take this, you're like, okay, we still have the x's that need to get on the same side, so you get rid of 1 over here. We have negative 10 equals 3x plus a 7. Now, just so you know, you could have just as well gotten rid of this 5x over here. But right now, we're going to subtract 7. Subtract 7. We have 3x equals a negative 17. Divide by 3. Negative 17 thirds. It's going to take a little bit on your paper. It's okay. It's good use of resources. Let's do another one kind of like that. 3 over 7 plus 2 sevenths x equals 5 sevenths plus 6 sevenths x. Alrighty. The thing that bothers you the most is the fact that there are a bunch of divided by 7s all through that equation. You're like, what do I do with them? You get rid of them. We want to get rid of these. They're all divided by 7, so we can times by 7. And we are left with 3 plus 2x equals 5 plus 6x. Like, ooh, I like that. That's nice. You just get these warm, fuzzy feelings generated all over. So subtract 6x. Now, you could have gotten rid of the 2x either way, but as long as you get those x's together so you can start peeling off, 3 minus 4x equals 5. Subtract the 3. And divide by a negative 4. X equals negative 1/2. It's not so bad. Now, some of you are wondering, it appears, sir, that you set up those problems so that they would work out nicely. They all have the same denominator all the way through. So we shall do one without. Aha! We have something that looks, now it looks worse. Because we can't really just multiply through by 3. That's not going to get rid of this divided by 4 in the least. Can't really just multiply through by 4, because then that one's not going to get got. And back when we did fractions, you remember we talked about how you could take any fraction and you can just change it. As long as you get the same denominators, you do the same thing to top and bottom, you can change it to any fraction. This one can be changed to 4/6, 6/9, or anything like that. Is there a number you can think of that 3, 4, and 2 will all go into? 12. 3 times 4 is 12, and 2 certainly goes into it. Let's take and change all of these guys even this 1 to a 12, and let's see what happens. So this guy we're going to times by 4, times by 4, times by 12, times by 12, times by 3, times by 3, times by 6, times by 6. Now you should note, we have not used our ability to multiply something on both sides of the equation. We have not done that. All we've done is taken this fraction and shown, hey, it has another name. There's another name that we could, complexify this guy up to. And so we get 8/12 x plus 60/12 equals 21/12 x minus 18/12. And now you can see kind of why we did that. They've all got 12s. All with 12s, we can get rid of those without any problem. Times by 12, times by 12, times by 12, times by 12, and they're all gone. You have 8x plus 60 equals 21x minus 18. Get the x's together, subtract 8x from both sides. So you have a 13x. Add 18 over here, and we have a, oh my word, that thing's going to work. Divide by 13, divide by 13. And we get x equals 6. Here's one where we have 2x over 3 plus 5 over 2 equals 1 over 6 plus x. Now, yeah, we can turn them all into that denominator. We could times this guy by 2 on top and bottom, and that'll make it a 6. Times this guy by a 3 on top and bottom, that'll make it a 6. And this one that's really over 1, we can times by 6, and we have now 4x over 6 plus 15 over 6 equals 1 over 6, that guy didn't need to change at all, plus 6x over 6. And now what happens when we multiply through by that common denominator? Yeah, look at that. 6's cancel right like that. And we are left with 4x plus 15 equals 1 plus 6x. Oh, we know how to do this. Subtract the 4x from this side and from this side to get them all on the same side. 15 equals 1 plus 2x. Subtract 1 from both sides and we get 2x equals 14. That was minusing 1. And then we divide by 2, and we get x equals 7. Excellent. Now let's look at this exact same problem in just a little bit different way. Most people will see how valuable it is to get rid of these fractions. And so there's kind of a shortcut to do it if you don't want to go through the whole process of getting them to the exact same denominator. So here we have the exact same problem. And to show you that we can go from here to here in one step. And this is the most common way of solving these problems. That least common denominator that was a 6, that was the key number. And if you multiply through by the least common denominator of 6 and multiply it in, distribute it to both sides everywhere, even without turning them all to 6's, it will still get rid of the fractions. Look at what happens. 6 times 2 is 12. So divided by 3, that's 4x. 6 times 5 is 30. Divided by 2, that's a 15. 6 times 1 is 6. Divided by 6 is 1. Plus 6 times x is 6x. And notice that we are at the exact same thing. There's no difference there. And then you can finish out. So getting rid of fractions, this is the key. Multiplying by the least common denominator. Now we'll have a summary of the three-step process of solving equations with any types of complexities in them, and a few examples to see how they work.
Today's an exciting day, one of my favorite days to teach algebra. We're going to talk about the three-step process to solving in all of its glory. Okay? What's so neat about this process is that rather than learning how to do 62 different problems or 100 different problems, we can learn one process and it can apply to all 62 or all 100 problems. Now we're talking about solving. So these problems definitely have equal signs. And this process will help us with all kinds of different problems. Problems that were big, problems that were small, problems with parentheses, problems with fractions. And this process will teach us how to address every single one of these different problems. Before we do it though, I once heard in a general conference talk, one of our general authorities say, out of complexity, find simplicity. And I think in everything we do in life, if something looks challenging and complex, if we can break it down into its simplest form, we then can come up with a solution. We can solve the problems of math or of life as we find simplicity. So, in your previous homework, we addressed the balance rule. Okay, whatever we do to one side of the equal sign, we must do the exact same thing to the other side. And these two principles, the addition and multiplication principles, were taught to you knowing that you must apply the balance rule. So we had problems like this in a previous assignment. And I think we've all come to the agreement that this is pretty simple. This is, in essence, simplicity. This is what we're trying to achieve. Okay? So we've got 3x plus 2 equals 14. And first I'm going to apply the addition principle. I'm asking who is sharing sides with x. Remember, our goal in solving is to get x all alone. So 2 is sharing sides with x. It's being added. The opposite of addition, as we learned in our previous assignment, is subtraction. Whatever we do to one side, we must do to the other. And so these cancel each other out. We're left with 3x equals 12. And then we ask, who is sharing sides with x now? 3 is. What is it doing to x? It's multiplying. We're going to do the opposite. The opposite of multiplication is division. So we're going to divide this side by 3. Whatever we do to one side, we must do to the other. So we will divide this side by 3. These 3's cancel, become a 1. 1 times x is just x. And 12 divided by 3 is 4. So the feedback that we got on this assignment is that this is pretty straightforward. This is simplicity. Now, as we look at these problems, again, I want you to join me in looking at these problems. These problems don't look simple. Lots of like terms here. Lots of variables going on here. Okay? Again, a lot of terms. Okay? In this problem, parentheses. And then here comes the real ugly, fractions. We've got fractions involved in this. So what our purpose is going to be with all these problems is basically, if you look at the 3-step process to solving, these 2 steps right here, you already know these. You've already learned them. And if you learn them, then we can call this simplicity. Okay? And we want to find simplicity by cleaning up the rest of the problem. So let's take a look at this process. The first thing, we're going to work a little bit backwards. I'm going to read it to you, but we're going to clean the problem up by getting rid of fractions. That sounds nice, doesn't it? Get rid of all the fractions. We're going to distribute parentheses, a tool that you already know how to utilize. We're going to combine like terms, another tool that you know how to utilize. And we're also going to get all of our variables to one side, and then we will have achieved simplicity, and our problem should look like this did. And we can apply the addition and multiplication principles as we've done in our previous assignment. So right now, all this doesn't make complete sense. So let's take one problem at a time, and let's do it. 5x plus 7x equals 72. I come to my process here. First, I ask the question, do I have fractions? Nope, you do not. Do you have parentheses? Nope, you do not. Do I have like terms? Yes, you do, absolutely. 5x and 7x make 12x. And 12x equals 72, all right? Now, where am I getting these questions from? The questions, do I have fractions? Do I have parentheses? Do I have like terms? Are all my x's to one side? I'm getting them from this process here. I am turning these statements into questions to make sure that I'm addressing each step. 12x equals 72. I have found simplicity. Who is sharing sides with x? Okay, we come here. Is anything being added or subtracted to x? It is not. But something is being multiplied or divided, and it is 12. 12 is being multiplied. The opposite of multiplication, again, division. Very good. So I'm going to divide this side by 12 and this side by 12. When I do to one side, again, I must do to both sides. 12 over 12 cancels, makes a 1. 1 times x is x. X equals 72 divided by 12. You guys know your times tables, your 12s? Very good. 72 divided by 12 is 6. Fantastic. Next problem. Okay, our goal again, we're trying to find simplicity. We're trying to clean this problem up and get to a point where we just have the addition and the multiplication principle steps left. We look at this problem up here. First question, do I have fractions? No, you do not. Do I have parentheses? Nope, you do not. Do you have like terms? Absolutely. Looks like you got a few. You got negative 7z. Okay, terms again are separated by plus and minus sign, so here's another term. It is a z, so there we go. We have another z term right here, and the sign before terms goes with them. Is this a z? It is not. Okay. And when we ask you to have like terms, we're talking about on each side of the equal sign. So this one here is just by itself right now. Negative 7z. So I guess going back to that, negative 7 and 17 are not like terms because they're separated by the equal sign. When I ask if you have like terms, I'm saying, do you have like terms on this side of the equal sign, and do you have like terms on this side? So because 17 is by itself, no other like terms. Negative 7 is by itself on this side, no other like terms. Negative 7z plus 2z makes negative 5z. Negative 5z minus 3z. What's negative 5 minus 3? Do we subtract 3 from 5? No, if we remember this is negative 5z plus negative 3z. We convert the subtraction to addition. And we have now same sign, negative 5 and negative 3 make negative 8z. Very good. Negative 8z minus 7 equals 17. Look at that. This problem looks like our simplicity problem over here. We have achieved simplicity. So we can apply the addition principle. Who is being added or subtracted to z? Yep, negative 7 is. It's being subtracted. So the opposite of subtraction is addition. We're going to add 7. What we do to one side, we must do to the other. We're going to add 7. Okay. These two terms cancel out. We're left with negative 8z equals 17 and 7 make 24. Very good. Who's sharing sides with z now? Negative 8 is. Good. It's being multiplied or divided? Multiplied. Opposite of multiplication? Division. So we're going to divide this side by negative 8. Can I just divide it by 8? I can't. That'll leave a negative there. I need to get z all alone. I don't want there to be a negative tagging along with z. Okay, if I just had positive 8, then I would be left with a negative z when these canceled out. I don't want to be left with negative z. I want to be left with z. So we're going to put a negative 8 here. These cancel. And what I do to one side, I got to do to the other. Divide this by negative 8. And so z equals 24 divided by negative 8. Very good. A positive divided by a negative is a negative 3. And z equals negative 3. Look at that. You simplified that problem and came up with that answer. Fantastic. Let's look at the next one. The next one, do you have fractions in this problem? Nope, you do not. Do you have parentheses? No, you do not. Do you have like terms? Yes, you do. Okay? And we're going to go back to what I just talked about. Do you have like terms on this side of the equal sign? We're not talking about joining them across the equal sign, but on this side. You do? Very good. You have 5y and y make 6y minus 7 equals, and then on this side of the equal sign, do you have like terms? You do. Very good. You have 7y and you have negative 5y, which make 2y plus 21. Great. So you've combined like terms, but notice this step. It says combine like terms and get all of your variables to one side. Okay, are all your variables on one side right now? They're not. We need to unite them all on one side. We cannot solve for the variable. We can't get the variable alone if it is divided across the equal sign. So we've got to isolate it to get it alone. There are two ways in which we can do this problem at this point. So I'm going to break this apart here. 6y minus 7 equals 2y plus 21. And then we'll put a little divider here. And 6y minus 7 equals 2y plus 21. Now, do you need to do this two different ways? You don't. This is merely to show you there are two different ways we can approach this problem. Then we're going to ask you which one you like better. So, if I want to get these y's all on one side with each other, what can I do? Okay? Got to use the balance rule. Whatever I do to one side, I got to do to the other. Very good. That's awesome. You got the idea here. I'm hearing we want to subtract 2y from both sides. And where did you come up with 2y? Right there. It was already there. And if we're going to get rid of it on this side, we'll subtract it. But what I do to one side, I got to do to the other. 6y minus 2y will make 4y minus 7 equals, these cancel, 21. Look at that. We found simplicity. Gorgeous. We love simplicity. Now, the addition principle. That's right. 7 is being subtracted from your variable, so we're going to add it. What we do to one side, we're going to do to both. Good job. These cancel. 4y equals 28. And then the multiplication principle. We're going to divide this side by 4, divide this side by 4, and y equals 7. Excellent. Now, a couple of you, when I asked you what we could do, I heard also, not only could we subtract 2y from each side, but possibly we could subtract 6y from each side. Yeah, let's go ahead and try that, see if that works. Okay, so this would cancel. 6y minus 6y is gone. Left with negative 7 equals 2y minus 6y, very good, negative 4y, and then plus 21 drops down. Again, your goal is to get the variable alone. So we have found simplicity. Who's sharing sides with y? Good job. 21 is being added, so we're going to subtract it. What we do to one side, we must do to the other. Negative 7 minus 21. These have the same sign, so we add them. We have negative 28. Always sounds confusing, doesn't it? When we have subtraction, that we're going to add negative 7 minus 21. But this is the same as negative 7 plus negative 21. Very good. Equals, okay, negative 4y. And then these cancel each other out. Now, who is sharing sides with y? Only negative 4 is left. It is being multiplied. We're going to divide. Are we going to divide by just 4? Very good. Nope. We're going to divide by negative 4. We want to get y all alone. And a negative divided by a negative makes a positive 7 equals, these cancel, y. Look at that. Are these two answers the same? They are. They are the same. Now, what's the difference? The variable is on one side, or the variable's on the other side, but the answer is identical. So which one did you like better? Did you like the one on the left or the one on the right? Yep, most students say that. They like the one on the left better. Why? Why did you like it better? Because it stayed positive, right? You dealt with a lot more negative numbers here, more potential for error. This felt a little uncomfortable. Some people prefer to have their variable on the left side. It really doesn't matter. But keeping things positive, so you subtracted here the smaller y value from the larger, it kept things positive. Here you took the larger one and subtracted it from the smaller one, it made it negative. But either way will work. Either way will work, anytime. Okay, good stuff. All right, great work, class. You guys are doing awesome today. We are solving all kinds of equations, and we're using the three-step process to solving. So, question, do I have fractions here? Okay, I do not. Very good. I have an equal sign, right? We've talked about this. We are solving. We're going to find out what x equals. Next step in the three-step process to solving, do I have parentheses? Yes, you do. You're going to distribute parentheses. What is the distributor? Is it 3 or is it negative 3, right? The sign before a term goes with it. So this is negative 3, and it's going to go to here and to here through multiplication. So this is 10 minus 6x, and then negative 3 times negative 1 is a negative times a negative makes a positive 3, and the parentheses is now gone, equals 1. Awesome. So we have distributed parentheses. Next question in the three-step process of solving, do you have like terms? Awesome. Yes, you do. 10 and 3 makes 13. 13 minus 6x equals 1. Good job. You have achieved simplicity. Look at that equation. There's no parentheses, no fractions, no like terms. All your x's are on one side. Who is sharing sides with x? 13 and negative 6 are. 13 is our addition principle. We're going to subtract this. What we do to one side, we've got to do to both sides. This cancels. I'm left with negative 6x equals 1 minus 13 is negative 12. Good work. Who's sharing sides with x? Negative 6 is. It's being multiplied. So we are going to divide. Divide this by negative 6. Good job. I'm glad to hear you say not just 6, but negative 6. We're going to divide this side by negative 6 as well. Gone. X equals. A negative divided by a negative is a positive. 12 divided by 6, 2. X equals 2. Great work. Great. So our final problem using the three-step process to solving. Here we have a very complex appearing problem. Our first question, do we have fractions? Yeah, we got a lot of fractions. So, our first step in the three-step process to solving is that we need to find the LCD, the least common denominator. Now, this is a skill that we've worked on throughout the semester, earlier on, or throughout the participation in the course that you're taking. And so, finding the LCD, we have 8, we have 4, we have 16. And we need to find the lowest common denominator. Let's return to our lessons from the past. We need to prime factorize 8. Pick two numbers when multiplied together, make 8 other than 1 and 8. 2 and 4. Great. That sounds like a good option. 2 is prime. We repeat the process for non-primes. 2 times 2, very good. And we circle all of our prime numbers to know that we've completed this. So we have 2 times 2 times 2. 4. Let's do these a little bit off to the side here. So we have 4. And we'll prime factorize that. Exactly. 2 times 2. Circle, circle. So we have 2 times 2. And then 16. Prime factorizing 16. 2 and 8. Very good. You could have picked 4 and 4. Either one would work. 8. 2 times 4. Good. And 2 times 2. Very good. So we have 2 times 2 times 2 times 2. All right. So our only factor that appears in all three of these numbers are 2's. 2 appears here how many times? That's right, 3 times. 2 appears here how many times? Good, twice. And 2 appears here how many times? 4 times. And so we learned a while ago that we count the greatest number. And so 4 is the winner. So we'll take 2 times 2 times 2 times 2 and multiply it out. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So our least common denominator is 16. Now that we have discovered that, we are going to multiply everything by 16. This is the balance rule. Okay? We're going to take this side and multiply it by 16, and this side and multiply it by 16. This means that 16 is going to come to this term, and to this term. 16 is going to go to this term and to this term. This allows us to obey the balance rule. Whatever we do to one side of the equal sign, we do the exact same thing to the other. This will give us 16 times 7 over 8x. Now, how do we know our terms? Again, they're separated by plus and minus signs. So now we'll have plus 16 times negative 1/4. Now, notice what I did there. I put a plus in between this, and I let the sign before this term go with it. And that helps us keep track of our negative numbers so we don't lose them in the process. So we're going to, again, say plus 16, because, and I'm going to do that in blue just to be consistent with our LCD here, times 3/4 x. times 3/4 x equals 16 times 1/16. And again, we'll have plus pen swapping here. 16 times x. All right. Are you all okay with me erasing this right here? LCDs? Okay, so we found our LCD to be 16. So it'll give us a little more clarity and room here to do this. Okay. Now, one mistake that students make is sometimes they think, well, we're going to get rid of fractions. That's my first step, is to get rid of fractions. And so they only multiply the 16 by the things that have fractions, and they forget to multiply 16 times that x because it doesn't have a fraction in it. But that would not be obedient to the balance rule, and that would then make the problem unbalanced, and we would get the incorrect answer. We must multiply everything by the LCD, whether it has a fraction or it does not. Now, are we all in agreement that 16 is the same as 16 over 1? We can put all these over 1. And when I do that, I can cross-cancel. 8 goes into 16 2 times. This was the purpose of finding the LCD, is this is going to allow us to get rid of all of these denominators and eliminate all these fractions. 4 goes into 16 4 times. This 4 goes into this 16 4 times. And these 16s just cancel each other out. And we don't even need that 1 down there. It's just going to be 16 times x. 2 times 7x now. My next step in the 3-step process to solving is to distribute parentheses. 2 times 7x makes 14x. Plus 4 times negative 1, what does that make? Negative 4, very good. And then I have plus 4 times 3x. Good, that is 12x. And this equals, okay, what happened to these 16s canceled? I have 1, and 1 times 1 is 1, exactly. So I have 1, and then I have 16 times x is plus 16x. My next step in the 3-step process to solving is to collect like terms, combine like terms on each side of the equal sign. So on this side right here, I have 14x and I have 12x. Good job. 14x and 12x make 26x. Awesome. 26x minus 4, that just comes down because there is no like term there. Do I have any like terms on this side? I'm hearing a couple of you say yes. We don't have like terms over here. 1 and 16x don't combine, but you're saying that 16x and 26x are like terms, but remember, they're on separate sides of the equal sign. So they aren't like terms, but we do need to address that. And the way we address that is our next step in this step states that we must get all of our x's or all of our variables to the same side. So how are we going to do that? That's right. Let's subtract 16x. What we do to one side, we must do the same thing to the other. So we're going to subtract 16x from this side as well. What else could we have done? Could we have subtracted 26x from each side? We talked about that in a previous problem. We could have. Okay. The choice to subtract 16x will help keep this positive. 26x minus 16x is 10x. Minus 4 comes down. The 1 comes down. These cancel. So now we have 10x minus 4 equals positive 1. We have found simplicity. Let's use the addition principle. Who is being added or subtracted to x? Negative 4. Very good. We're going to add 4 to this side and add 4 to this side. These two will cancel. We're left with 10x equals 1 plus 4 makes 5. And then the multiplication principle. 10 is being multiplied, so we're going to divide it. Very good. So we'll divide this side by 10 and this side by 10. These cancel. And let's go ahead and write this right here. X equals 5 over 10. Now we must always simplify our fractions. Okay, so 5 over 10 equals what? Great. X equals 1/2.
to the boards! Hello and welcome back to the boards. It's time for you to go to the boards and get some practice with solving equations with fractions. There's a three-step procedure when doing these types of problems. First, you want to simplify by distributing into the parenthesis. Then by eliminating fractions by multiplying each term by the common denominator. Then you want to make sure to combine your like terms and get the x's to the same side. Next, you need to add or subtract. And then last, you need to multiply or divide to get the x by itself. So here are 3 questions for you we'd like you to try. Go ahead and pause the video now. Use these procedures. Let's see how you do. And when you're done practicing, unpause your video and we'll see how you did. Okay, great. It's time to practice question number 1. I've got 2/3 x plus 5 equals 7. First thing I need to do is distribute parenthesis. I don't have any parentheses, so we don't have to worry about that. Next, we need to eliminate fractions by multiplying by the common denominator. Now, we do have fractions. See this 3 down here? So therefore, we need to multiply every term by the common denominator, which in this case is 3. So I'm going to multiply each term, this term by 3, this term by 3, and this term by 3. I'm multiplying each term by 3. Okay, great. 3 times 2/3. Well, that 3 times 2 is 6. And 6 divided by 3 is 2. So I'd be left with 2x plus 3 times 5 is 15 equals 7 times 3 is 21. Great. So we eliminated the fractions. Notice how this problem no longer has fractions in it because we multiplied everything by the common denominator. Okay, next, we need to undo our, we need to combine like terms. We don't have any. So now we can undo our addition. I'm trying to get x by itself, so I'm going to minus 15 to both sides. I'm left with 2x equals 6. Now I need to undo my multiplication. I've got a times by 2, so the opposite of times by 2 is divide by 2. And so my final answer is x equals 3. Moving on to question number 2. I need to first distribute the parenthesis. I do have a negative 4/5 that I'm going to pull into the parenthesis here. And I'm going to get negative 4/5 x plus, 4/5 times 3. I'm going to do 3 times 4. That's 12/5, but it's going to be a minus 12/5 equals 2 plus 3x. Okay, so we distributed the 4/5 in. I now need to eliminate the fractions. Oh, the common denominator is 5. So I'm going to multiply each term by 5. So this is going to get multiplied by 5. This is going to get multiplied by 5. This is going to get multiplied by 5. This will get multiplied by 5. We're multiplying everything by 5. When I do that, here my 5's cancel out, and I'm left with negative 4x. Here my 5's cancel out, and I'm left with minus 12. Equals 5 times 2 is 10, plus 3 times 5 is 15x. So I eliminated the fractions by multiplying by the common denominator, which was 5. Now I need to combine my like terms. I got to get my x's together. I'm going to go ahead and minus 15x to both sides. That way I get all my x's here on the left side. That's negative 19x minus 12 equals 10. I now need to undo my addition and subtraction. I've got this minus 12, so I'll go ahead and plus 12 to both sides. Plus 12 plus 12. I'd be left with negative 19x equals 22. I'm going to divide by that negative 19. That's the last step. Divide by negative 19. So my final answer is 22 over 19, and the answer is negative. Okay, great. Question number 3. I've got this 2x plus 5 all over 3 equals 4 minus 3/4 x. Okay, so let's go through the steps here. Step number 1, distribute parentheses. There are no parentheses in this problem, so we don't have to worry about that. The next step is to eliminate fractions by multiplying by the common denominator. Ooh, look at this. We have fractions. We have this 3 down here and this 4 down here. So I got to find the common denominator between 3 and 4. What number will 3 and 4 both go into? Oh, it's 12. So I'm going to multiply all the terms by 12. I'm going to multiply this term by 12 and this term by 12, and this term by 12 as well. Let's put it here in front. Okay, when I do that, my 12 and my 3 will cancel out. 12 divided by 3 is 4. I'd be left with 4, 2x plus 5 equals 12 times 4 is 48 minus 12 times 3 is 36 divided by 4 is 9x. So notice we eliminated the fractions. This problem no longer has fractions in it because we multiplied by the common denominator. Okay, great. Let's go back and distribute into parentheses. I ended up with a parenthesis here, so I'm going to take the 4 in. I get 8x plus 20 equals 48 minus 9x. Again, I did that by just distributing the 4 into the parentheses. Okay, good. No fractions. Combine like terms. We do have like terms. We got to get our x's to the same side. I want to move them all to the left. So I'm going to do plus 9x to both sides. Excellent. 8x and 9x, that's 17x plus 20 equals 48. Good. So we did that. We combined our like terms and we got them to the same side. That's important. We should probably put that here in the rules. Same side. You want to get those x's to the same side. Now we need to undo our addition subtraction. I've got a plus 20. So if I minus 20 to both sides, I'd be left with 17x equals 28. My last step is to undo my multiplication. I've got this times by 17, so I will divide both sides by 17 to get the final answer of 28 over 17. And that's our answer. Okay, well, nice work going to the boards and solving these equations with fractions. These 3 procedures will help you in your quest as you work on your homework and for the rest of this section. Keep working hard and good luck.